Hello, guys, and welcome to our first official day. I know we've had a couple days now, but our first official day of actual accelerated geometry material. So, hopefully, everybody has one of our math Bibles here, our Geo Bibles. And this is going to have the first three chapters. And I hope for several of you guys, I'm going to get to see you back in person here soon. So you won't have to do these three chapters, outside of the classroom with me. But I know for a little bit at least, all of us will. And so this is kind of what you can expect here. If you've never had me before, or even if you have had me before, this may look a little different. You're going to notice that up top, I've got the actual chapter standards here for the test itself. So that's kind of interesting. You can see the question numbers, what standards are going to go with which, how the test is broken down. And normally, multiple choice will be 40%, short answer will be 20%, and then each free response will be 20%. That generally will be the case here as far as all 100% of your test. Now, if you've had me before, you know that whenever I like to get into a lesson, I like to a lot of times have you guys help teach it, help come up to the board, help come up to the document camera, make posters, do a lot of different things. And so we'll just change it up and be a little bit more adaptive this time. But I still know you guys are going to work this along with me. You'll be able to ask questions through Google Meet, through email, through Reminds. We'll still have plenty of options, and I know that you guys are going to, as my accelerated students, are not going to be afraid to ask questions and to do your work, and know that it's okay to fail as far as asking, making mistakes and things like that, as long as you don't give up and as long as you keep learning and you keep getting better. And actually, before we start, I just wanted to give you guys a chance to really kind of have a face-to-face and just say that I'm really excited for this school year, and that I know math can be challenging. It was always my least favorite subject, and geometry especially was something I always really struggled with. But it was one thing that I didn't give up. I had some friends that could really help me learn it, even whenever maybe my teacher didn't do the best job explaining it. That may happen. This is only my second year teaching geometry, actually, but I had such a great time last year and learned so much myself that I'm very, very excited to give it another go and to see what we can do. And hopefully by the ends, if we're not geometry masters, maybe we'll be geometry warriors. We'll go with that. Let's jump right into the lesson. So, this being the first day, I'd like to welcome you to geometry. And you can see right here, we're going to have the chapter title and the day number, along with, several of you guys have probably seen this before, along with the standard. So you can see today we really only have one standard, being able to identify and write conditional statements. So these are statements that we can then use to form conclusions. Sometimes these conclusions are true, sometimes these conclusions are false, and we'll learn a little bit more about that. But I'm going to give you guys a second to kind of read over, and then I want you to just kind of answer a few questions here as far as what we know about geometry, and then as we read, what you're learning and seeing about different terms, because in geometry, vocab is everything. Man, I don't know what happened. All of a sudden, Euclid's looking kind of ticked. But as you can see, we've got geometry, which is really just the study of the measure of the earth. But our boy Euclid, this is our guy. This is the man right here. He was a mathematician and a teacher. Holla at your boy. He combined a lot of different ideas in order to come up with a streamlined, more efficient version of geometry that is so good, we actually named this version after him, Euclidean geometry. And so going back to our standard for the day, we're going to be dealing with some major terms here. Conditional. These are statements that are formed exclusively with if, then. For example, if you get punched in the face, then you might cry. Now, some of you guys might say, oh, I'm a tough guy. That's not going to happen. That's not a true statement. Well, I hope you never have to find out. These don't always have to be math related, just like the one I just gave you. But the problem is, these are always true. So no maybe about it. If you get punched in the face, you will cry. That's tough. Now, if it is raining, then I will carry an umbrella. Now, again, I know that may not be true for everybody, but in general, you probably want to have some kind of protection there if it's raining. Now, here's where things can get a little tricky. We've got something called a converse, not the shoes. And some of you guys have heard this word before. This is formed whenever we switch the hypothesis and the conclusion. Now, these are not always true. So if you carry an umbrella, then it is raining. That's not always true. Maybe you're just kind of weird. You just like to carry around an umbrella. Maybe you're not weird. Maybe it's just your aesthetic. That's just your style. You're just an umbrella hipster. So here's an example for you. If I am sleeping, then I am breathing. Now the converse, if I am breathing, then I am sleeping. That definitely is not always true, although for some of us, we're going to get a little bit more sleep than we'd like to admit. We're like cats. We sleep 19 hours of the day. So a word we're going to be dealing with a lot this year is definition. All that is a statement that gives meaning to a term. So you see these in dictionaries all the time. Now, here's the thing about converses of definitions is that they are always true. So even though a converse may not always be true, a converse of a definition is always true. So that's kind of interesting. We'll give you an example of that a little bit later. How about this? May be a word you've never heard of, postulate. So a postulate is accepted as truth without proof. Like whenever people falsely say that LeBron James is the best basketball player of all time, some people accept that as truth without proof because there is no proof. He's top 10 probably at this point. Definitely not the best though. Now a theorem. This is a statement that must be proven before being accepted as truth. For example, saying that Michael Jordan or Kareem Abdul-Jabbar or Wilt Chamberlain or Bill Russell are the greatest basketball players of all time, any of them, no matter which one you pick. I would accept all of those answers. That would be a theorem. That has been proven and is accepted as truth. So a postulate, here's an example. Here's an example. Here are those definitions kind of laid out for you. So a postulate and a theorem. So let's look at some examples, guys. So give the hypothesis and the conclusion of each statement. So you're going to see what we have here. These are conditional statements. They are if-then statements. That's what that means. So our hypothesis would be the first thing we see here that goes with if you are funny, then the conclusion we can draw from that would be you're going to make people laugh. That's pretty self-explanatory, isn't it? Kind of a setup and a payoff. Hypothesis is what we are assuming. Conclusion is what that would mean. And so if you want to, you can obviously practice this on number 2. I'm going to reveal that answer, but you are more than welcome to practice it if you want to pause the video now. Back to it. So there's our answer if you'd like to take a look at that. Now, really, all we're going to be doing here, I know you guys are intelligent. I know you also love to not write a lot if you don't have to. So I'm going to give you a second, but I bet a lot of you guys it's already clicking. What's really the only thing we're going to have to do here? That's right. I feel like Dora the Explorer right now. We're going to add an if before the hypothesis. So if a man lives in Houston, we're going to change that period to a comma. Come down here. Then he lives in Texas. If a man lives in Houston, then he lives in Texas. Now, here's a real question. Would the converse be true? Not necessarily. He could live in Austin. He could live in Dallas. He could live in Fort Worth. I don't know a lot of other cities in Texas, El Paso. But no, just if he lives in Texas, then he lives in Houston, is not necessarily true. So the converse is not necessarily correct, much like the conditional statement, which is true. And you can see the same thing with the second one. If a number is prime, comma, then the number has exactly two divisors. That is true. How about this one? If the number has exactly two divisors, it is a prime number. If you can believe it, the converse is true. If a number has exactly two divisors, it is going to be prime. So that one works both ways. So how about that? And speaking of converses, I'm going to give you guys a second to practice numbers 1 and 2 here and see what you think about those. And then if you're needing some extra practice, I'll let you guys work on 1 and 2 as well. But be careful, because what I do want you to tell me is I do want you to tell me whether you believe these are true or false down here. Let me know if you think these number 1 and number 2, whether you write the conditional statement or not. Make sure you let me know if you think those are true or false. You can pause the video now. So taking a look here, we see that starting with number 1 and 2 up here, we've got a false and a true statement. So again, sometimes converses are true, sometimes they are false. Down here, we've got both false. If a number ends in 5, it is not going to be an even number. And if a person is left-handed, that does not necessarily mean they are male. That's not an equivalent statement. So that's kind of how converses, conditional statements, and truth and falsehoods are around them. So we'll pause. If you need to stretch, stand up, you can pause and just kind of do that. I don't know if you're like me. I'm a little restless. I'm shaking in my seat right now, wanting to move. So next up, we've got Venn diagrams. Now, you guys have probably seen these in your English classes, but these work in geometry, especially with logic. So these are used to illustrate how sets of things can satisfy what's going on with the hypothesis, as well as help you better understand what conclusion you can draw from that. So let's look at the example they gave us here. So integers. Integers are every number that's not a decimal. -3, -2, -1, 0, 1, 2, 3, 4. Those are all integers. And you're going to notice that that whole circle is represented by integers. Well, then what's the difference here? What's a whole number? Well, a whole number is like an integer, except it is no decimals and no negatives. Whole numbers are numbers we deal with and see a lot of times in our day-to-day lives with counting. You know, 0, 1, 2, 3, all positive except for 0. So here's the thing. We need to write a conditional statement that is true. So could we write, if a number is a whole number, then it is an integer? Would that be correct? Or should we write, if a number is an integer, then it is a whole number? And some of you guys can tell by the Venn diagram, clearly we need to work small to big. If a number is a whole number, so if it's in this little circle, we know it's going to be in the bigger circle too, because that little circle is inside of the bigger one. So if a number is a whole number, then it is an integer. Does that make sense? If something is smaller inside this circle, then clearly it will also be represented by the rest of that big circle. Because we know that whole numbers are also integers, even though some integers are not going to be whole numbers. All right, last page, last thing right here. What I want us to do is I want us to draw a Venn diagram now. Let's see what we can do here. I'm a terrible artist, but I'm going to give it my best shot. So if an angle measures 100 degrees, then it is obtuse. If you want to go ahead and pause the video and try this, you are more than welcome to. Okay, if an angle measures 100 degrees, then it is obtuse. So we've got our circle, and then we've got our littler circle. So the question is, which one is going to be where? Well, let's think about this. If an angle is 100 degrees, will it be obtuse? Yes. If an angle is obtuse, will it necessarily be 100 degrees? No. So, obtuse is our conclusion here. It is the overall truth. Because if an angle is 100 degrees, guess what? It's going to be obtuse. But will every obtuse angle be 100 degrees? No. You could have an obtuse angle that's 105 degrees or 130 or even smaller than 100. You could get 95. So obtuse can represent a lot of different angles, one of which being 100. So last thing here before I turn you guys loose on some practice MC, multiple choice. I'm going to give you a chance to practice this one. I need you to write 3 conditional statements that this Venn diagram displays. So you can pause the video and unpause when you're ready to see if you were right. Let's see if you guys agree. You may have done these in a little bit different order, but I'd say we have all 3 none the same. And I know some of you guys are going to be saying all baseball players aren't athletes or pitchers aren't athletes. You know, you see some people in the majors who've got big guts or, you know, who look out of shape, but trust me, I played baseball for, I think, 11 or 12 years, and, I mean, some of those dudes, they're strong, they're fast. So try not to give your high school players grief either, because they are some good athletes for sure. To have that kind of hand-eye coordination, to move around the bases, to throw a ball that fast, you know, to be able to throw a ball from that far out in the outfield or from third to first to hit a guy run into the first plate or to first base. I mean, much love from a former baseball player. And so we're going to wrap up today, guys, by knocking out 4 practice multiple choice questions. And so I'm actually going to have a quizzes lined up for you guys tomorrow to see how we do on these, and also to award the virtual Jolly Rancher to my winner and to give hand claps of praise to second and third place. So there's a lot on the line here. This is for all of the virtual Jolly Rancher and hand clap of praise. This is a sweepstakes right here. This is for everything. So don't miss your chance. And so, guys, I will talk to you and see you tomorrow. Thank you.